Good afternoon. Thank you for joining us. Nick and myself are going to spend the next hour and just go through some more advanced topics when working offline with ArcGIS Runtime. And a lot of these topics have come up in conversations that we've had with users over the last few years. And so we thought we'd add this new session this year to the developer summits to cover these topics which we think you'll find interesting if you've been using Runtime for a while, or even if you're brand new to Runtime. So we're going to cover what you can do in terms of optimizing your data. And that has a huge impact on the ways that you can deliver content to your offline devices. We talk about working with version data. We talk about strategies for sync and how it's important to really understand how sync works and the direction that you perform syncs in. And then we finish off with a little bit of information on data encryption and a few other considerations. So let's get right down to it and start talking about data and how you optimize the data for your best experience when working offline. There are several methods available to you to achieve the best workflow that's possible for your use case. You can think about how you work with and design your maps and the layers and the dataset design. You can think about the sort of the tools that you're going to be using as part of the runtime SDK or even the ArcGIS Online or ArcGIS Pro. And there are a number of API options which allow you to work with data differently. And the more knowledge you have about the user, about your user's data and their requirements, the more optimization that you can perform in the workflow. And so it's really about understanding your use cases very well so that you can maximize the performance and make sure we're not transferring data that we don't need to transfer or also, for instance, through a web service request when we could have some of the data, for instance, Basemaps, could be sideloaded on the device. So let's just look at map and layer design. I think the rule of thumb here is just because it's easy doesn't mean it's right. It's very easy for me to create a map, load all my layers into it, not really think too much about the structure to the data, and I can publish that map to online and I can take that map offline. And it does work. The system does allow you to do that. But it's not necessarily the right thing to do. So think about the currency of your data. How often is the data in that map changing? Are all the layers changing, or is there only really one layer or two layers that change a lot? Well, if that's the case, you could put all the other layers potentially into a base map. And you could perhaps create a vector tile package and move that data onto the device as a separate step. And especially if the data doesn't change on a regular basis, base map data typically changes once a quarter, or maybe even less frequent than that. That's the only time that you would need to get that data on the device. Whereas the data that you're editing or the data that's being edited on the server that you want to keep current, that could be changing hourly or daily. Try and limit the amount of data that you're transferring on the regular basis when you're performing sync operations. That's the key. And think about how you can partition your map into very volatile data to less volatile data, and think about treating them differently. The other thing that you can do is think about what needs to be a feature layer. And because a feature layer allows you to edit the content, it allows you to select the features, it allows you to identify the features. But not everything needs to be identifiable or editable. If that's the case, move it into a Basemap and have a vector tile layer supporting that content. The symbology will all be honored. It's just that you won't be able to edit or identify these features. But if you don't need to, you can greatly enhance the performance by moving it into a vector tile set. Basemaps, especially imagery basemaps, are perhaps the largest amount of data that you will take offline when you take a map offline. And anything that you can do to limit that or remove it entirely will greatly improve your workflow performance. And for that, we have recently added Basemaps by reference. And this allows you to online tell the online system, when this map is taken offline, if this base map by reference, TPK or VTPK, exists on the device, then there's no need to take the base map offline, and the offline map will use the pre-existing base map file which is already sitting on the device. And if the base map file is missing, then the offline map will download the base map from the online system. But it will first of all look to see if it's got a local copy. And then you, as a separate process, you sideload or even download these TPKs, VTPKs onto your device so that they're available for you to use. So to show us this in operation, we're going to hand over to Nick for the first demo. Nick.
So Basemaps by reference allow you to take a web map offline without pulling the base map down. If, for example, you have a local base map, a tile package or a vector tile package already on the device that you want to make use of. This is useful, for example, where you have field workers with a large coverage area and they jump around day to day from part of the area to another part of the area, and you can just install a single base map that will always cover them, and then just pull their operational data down whenever they need it. So it begins by configuring the web map. If we jump to the offline settings in the web map and into the advanced options, we can see down here we've actually specified the device will use a tile package it already has, and we give that tile package a name, naperville.vtpk. So what that looks like on the device is something like this. Here we have an offline map again, or rather an online map that's being configured with that Naperville VTPK in its advanced settings. And now when I take this offline, you can see in the jobs here, it's only started one job. Ordinarily, it would start two jobs, one for the base map and one for the operational tasks. If you were in our earlier session, you would see that. In this case, it's just creating the geodatabase of the operational data. It knows that it can skip pulling the base map component down because the web map has been configured that way. So in a second here, it will download the data, and now we have our offline map. We can see just the operational data for the area we looked at, but if I zoom out, we can see I've got this entire Naperville vector tile package here that would cover my work day to day. So let's see what that looks like in code. We begin by specifying an area of interest that we want to take offline. We use our offline task that was initialized against the online web map, and we generate offline map parameters with that area of interest. We jump in to creating the job that generates that offline map. Before we do that, we take those parameters we just got and we set the reference base map directory. Now, in this case, it's going to be bundled with the application. We can see up here, we've got a Naperville VTPK file included in this app that I've built. And so this is just telling the runtime, you can find it at this location. And from that point on, everything else is exactly the same. Runtime goes ahead, generates the offline map job, runs that job, and when it's finished, we have a map using the local VTPK that was configured, as well as the operational data that was downloaded on demand.
Thanks, Nick. I think you saw how quickly that map came offline because it wasn't having to deal with the base map whether it was downloading the base map or just preparing the base map ready to be downloaded. Another way that you can optimize is to think about the map area that you need to take offline. In earlier versions of the runtime, we could only take envelopes offline, so rectangles. And if you had a linear feature, for instance, a road corridor or a utility line, that was sometimes very ineffective because you were downloading a lot of content that you were not interested in. So a couple of releases ago, we added the ability to create Polygon offline map areas. And you can do this in the ArcGIS Online map editor. And that way, when the data gets taken offline, it only uses the data that you really want. And it can be extremely efficient, as I say, especially for road corridors and utility lines. So I'd like to pass back to Nick, and he's got a demonstration of how you set that up on the ArcGIS Online client.
When we first introduced offline capabilities with the runtime, the only way to specify an area to take offline was to specify an envelope, a large rectangle. For many use cases, that involves taking offline a lot of data that you wouldn't ordinarily need to take offline, just to support the small area within that envelope that you're working with. We've introduced the capability to specify a polygon to take your map offline. And let's look at what that looks like and what an impact it can have for you. So here we've gone to our offline settings for a map that covers some California highways. Now, if we jump into the areas here, you'll see two distinct areas. There's this red highlighted outline of a polygon buffer, and there is the blue highlighted full extent. Now, when we look at the difference in size between the packages that are generated, the full extent generates a package of almost 100 megabytes to download, including the roadside data and the vector tile base maps. When we compare that to the polygon buffer, we've only got 33 megabytes to download. You can see that's about a third the size. It's a big difference. And if you're working on even larger areas with more dense data than this, the impact will be even greater.
Thanks, Nick. Perhaps one of the biggest optimizations that you can make is thinking about pre-planned or on-demand workflows. With the on-demand workflow, it's a productive authoring experience. You have little overhead to support offline use. You literally just have to create your online map, go into its properties and enable offline support. And that's about it. The data editing is supported using the synchronization framework. The thing that you've got to be aware of with on-demand workflows are how many numbers of users are you hoping to support, and when are they likely to be going offline? Because if you've got a large number of users and they're all going offline at the same time, for instance, at the start of the workday, the server is going to be generating a lot of offline maps. And that requires back-end database access. It requires a server to process, package up these maps, and then the clients to download them. So there's quite a lot of work. And so it doesn't scale to thousands of users going offline in the morning. Tens to 100 or so, there's usually no problem with it. But thousands of users, on-demand workflow isn't the one you should be considering. The pre-planned workflow is what should be considered. This is where the author of the map or the administrator of the organization can select several areas, and you can upfront create the offline maps packages. And these are stored on the server, ready for download when the users come into work. The user comes into work, selects a map area to take offline, it downloads the area. Before they go offline, they should perform a sync just to make sure that it's up to date, because changes may have happened on the server since the packages were created. But then once they've performed that sync, they can safely go offline. And that sync will generally happen fairly quickly because not too many changes will have happened on the backend server since the package was created. And you can automate, using the Python API, the creation of these packages. So we've got a productive authoring experience. Again, of course, it supports data editing with sync. And the field areas being restricted to the admin to the areas that the admin selected, you can consider that a plus and a minus. Some people would say, yes, that's great. My users will only be working in these areas. I don't want them taking random areas of data offline and taxing my servers. But it could be negative as well. If you're working in a very fluid environment where there's lots of incidents covering a large area, and it's difficult to know where these are ahead of time, then the on-demand workflow might be more appropriate. But a lot of it's to do with if you like, the size of area. With vector tiles and the mobile geodatabases, we can cover a fairly large area, and we could cache these pre-planned on the server. So for working in a city, for instance, you could possibly cover that entire city with one area. Working in a state might be more challenging, and you probably want to divide that up into multiple areas. Scheduled updates is an optimization on the pre-planned workflow. This is for read-only workflows. So the way that this works is when you create the offline area initially, it creates the web map, it creates the geodatabase, has all the features inside of the area that you've defined, and it's sitting on the server, and that's what users take offline. On an hourly basis, daily basis, you could create an update to that. It doesn't recreate the whole thing, it just creates a small database with the changes. And there's a number of these can be created when the client comes to download the map. If it doesn't have the map initially, it'll download the original package and then these small delta files and apply them. If it does have the data on the device already, it'll only download the delta files that have been created since the last time it performed a sync. And this can greatly improve the performance for read-only workflows. And we've got a number of customers in the utility space which are using this very workflow, and they're supporting workforces of over 10,000 users going offline on a daily basis, where the most important thing that they need on their truck before they leave the depot is to have the most current map available. And so overnight, these updates are created, and then the crews come in the morning, and very quickly they can synchronize with these changes just by pulling down the deltas, and then go out in the field knowing that if they lose connectivity to the network, they've got the most up-to-date map data available. And yes, as the last bullet there really talks to that. It's highly scalable. So to show us how you set these up and configure a scheduled update, I'm going to pass it back to Nick.
So let's take a look at scheduled updates. We'll start with what it takes to configure scheduled updates on your map. So here we have that same map again. It's configured for offline. It has 5 available map areas. We're going to jump in, look at these areas, and take a look at the configuration for one of them. Now, when we create these areas, by default, it'll just package them up afresh every so often according to the schedule, here every week at 1:21 p.m. If we enable scheduled updates, what the runtime will do is it will still generate that package, but it'll also generate a tiny delta package of only the changes to the data that have applied since the last package was updated. You can imagine we could do this every day. And so we'd have a tiny delta representing every day, and a map package sitting there waiting for somebody who hasn't already downloaded it so they can get the current state. So all these things are sitting there on the server, generated by ArcGIS Online or ArcGIS Enterprise. Let's take a look at what that looks like when it's being downloaded by an application. So here we have an iOS application. We can see here in the middle, there's an area that doesn't have any data on it at the moment. I happen to know that when I pull the scheduled updates down for this offline pre-planned map that we have on the device, it'll fill in some data there. So I'm just going to tap on the map to kick that off. Now, the first thing that happens is we find out how much these deltas would, how large these deltas would be if we wanted to download them. Yes, I do want to apply these. So we go ahead, download them, and apply them very quickly. You notice how fast that was. We didn't pull down the Basemaps. We didn't pull down the entire package. We only pulled down these two deltas that represent the changes that have happened since I got the original map downloaded. And then we apply them in sequence and bring our data up to date. If we look at this in code and see what's happening, it's really straightforward. We take that offline map sync task again, initialize it with our local map. That's the pre-planned map we previously downloaded. And we check for updates. Now, we find out that there's some available, and we can find out how much space they'll take, how large they are to download. So here I just pop up that alert that asks the user if they want to download, and of course I did. And we jump in here, get the default offline map sync parameters, and we just call offline map sync job.start. What this does is it goes ahead, downloads each of those Delta packages, applies them in turn, and comes back when it's finished. There's really nothing for us to do. There's one exception to that, though. Under some circumstances, the runtime will decide that it's actually more efficient to download the latest packaged up entire package and replace what's on the device already with that latest version. That can happen under two circumstances. The first is if the deltas actually turn out to be larger than the latest package that's sitting there on the server waiting, or if that breadcrumb of deltas from the last time that you downloaded the package to the device to today is broken in some way. By default, the server, ArcGIS Online and ArcGIS Enterprise, will keep 5 days worth of deltas. So if the last time you downloaded a package was, say, 7 days ago, and there are deltas missing in between, Runtime will figure out, well, actually, I can't bring you up to date with the deltas that I can download. I'll just download the latest package. And in that case, we have a flag here on the result that's returned to us that says you actually need to reopen this mobile map package. And in that case, we just close what we had already and we load the new one, and the runtime takes care of everything else.
Thanks, Nick. Finally, when it comes to optimizing data, there's the API options. The API has a default set of options where it will do the right thing for many use cases, and that's why they're the defaults. But when you've got specific workflows or you want to really optimize to the utmost, you have fine-grained control using API overrides. And these allow you to override certain aspects of the offline data flow and really give you really fine-grained control down to the individual layer types, how they behave, etc. Now, clearly, API overrides only work with the on-demand workflow because you're really tweaking at runtime exactly how the data is going to come offline or be prepared on the server. With the pre-planned workflow, that thinking has all been done up front by the system administrator when the packages are created. Now, the programming model for how overrides works pretty straightforward. When you create your task to take the map offline, you can generate the offline map parameters, and then you can see what the defaults are, and if you want to change the defaults, you can. So you can change the min-max scale, for instance, for the tiled layers to come offline. You can change the area of interest. You can determine whether attachments are taken offline or not. But it's always good to start with the defaults and then go and change them from there. And you get these defaults by calling generate offline map parameters. There are a set of advanced overrides that allow you to modify the underlying parameters of the individual services So whether you're taking features offline, so that's your generate geodatabase parameters, whether you're taking vector tiles offline, export vector tiles parameters, or whether you're taking the imagery tiles offline, export tile cache parameters. And once you've got these parameters, you can tweak them and set them back into the process. You can create an offline map job, and that map job will honor all the settings that you've defined. So I think this is best seen in a demonstration, and we're going to hand it back to Nick for his last demonstration of the day.
So here we have a web map. I'm going to take an area of it offline, zoom into a small area, and I'll just kick off that offline process. You can see here the offline process on demand is kicked off 2 subjobs, one for the vector tile base maps and one for the operational data on top. So it's downloading the geodatabase of operational data. It's now downloading the vector tiles, and we have a map on the device. Now you can see here that some of the operational data extends beyond the extent of the base map. Now that's because when we pull data down, if we intend to edit it, we want the full record there. Otherwise, as we edit and post changes back, we could end up corrupting the source data. But what if I wanted enough base map to cover that area as well? So what I can do is I can provide some overrides. Here I'm going to run it again, but this time I'm specifying an additional override to expand the area of the base map. Okay, so now we can see that same operational data extended beyond the area of interest, but we have an even larger area of base map that's been clipped and brought down. So when we look at the code, it looks a little bit like this. We start off by creating our offline map task pointing at the online web map. And we get some parameters to take that offline given the area of interest. The next bit we do is we generate some overrides. So given these broad parameters, we want to get very fine-grained parameters that we can configure and tweak precisely to our needs. So this is layer by layer, property by property, how we want to pull that information offline. So we provide the parameters to this generate offline map parameters overrides function, and that comes back with these fine-grained overrides that we can tweak bit by bit. So we find a key into the overrides for the particular base map layer that we're after. And we've got a buffered area of interest where we take the original area of interest and use the geometry engine to just expand it by a bit. Then in the overrides, we update the area of interest for the particular key, either for tile cache or for vector tile cache, because we don't know necessarily what the web map has, so we're just being safe here, and we specify that larger buffered area of interest. When we're done with that, we just jump down, create ourselves a job in the usual way, only we call the generate offline map job call that also takes these overrides on top of the parameters. And we start the job, and runtime handles the rest.
Thanks, Nick. So finally, when it comes to optimizing your data, you can work with, instead of the map and using API overrides to control behavior, you can actually go to the individual services and deal with them directly, whether you're working with imagery tiles or vector tiles or geodatabase feature layers. And you can control exactly what gets taken offline. If the offline map task with its overrides doesn't give you all the functionality you need, you can always dip down to the individual tasks which take the components of that web map offline. Also consider the workflows of your user. For instance, if your users are only creating new content and they don't need existing content for context, you can simply download the schema. And once the schema is on the device, your user can create their new content and then upload it to the server when they're done. And that would greatly speed up the download aspect. When dealing with attachments, attachments can be large. Do your users need attachments? Or do the majority of them need them? If they don't, you might want to enable by default, don't download my attachments. Make that an option for the users that actually need the attachments. Definition queries can be set as part of your sync operation so that you only download the features that meet the definition query. Now bear in mind, if you do that, if you're editing your content, all the features that you're editing must also satisfy that definition query. Otherwise, you will not be able to push them back to the server because for that offline map, they don't meet the criteria, so the server will reject them. And then finally, when you're working with ArcGIS Basemaps, we have a set of for export versions of the vector tile services. By default, the vector tiles can support multiple languages all over the world. And to support all these languages, we actually have to bundle a large number of fonts. And if you're working in an area where you don't need the font library, for instance, for Japanese or Chinese or Thai, then you can use the export-only versions of the vector tile services, and they have a much reduced font set. And so the best thing to do there is test based on the area that you're going to be working in, test your area of interest. If the base maps look good and all the fonts are coming down for your area, then I would highly recommend use that version, and that'll reduce the size of the base map package, the vector tile package that comes down quite a bit. All right, so that was kind of ways that you can optimize your data to go offline. Let's now have a look at version data, because that's often a question, especially in editing workflows. How does Runtime handle versioned data? How are the edits applied? Well, typically, when you're editing your data with Runtime and you apply changes back on the server, they're just applied directly to the service. And the rule is the last in wins. So if two editors out in the field edit the same feature, it's the last one that performs the sync whose edit sticks. Now, if you want to support a notion of multiple versions, you can use versioning, but it adds to the complexity of the back-end processing. The complexity in many use cases doesn't exist to the end user out in the field. They see their data, they're able to perform their changes, and when they perform sync, the data is going back to the server. It's after that there's added complexity, because you've got to run a reconcile and post operation. And depending on the number of editors that you have, that can be quite a lot of sort of background processing that's got to be performed on a regular basis. So let's take a look at versioning. There are two ways to work with traditional versioning. So we've got traditional versioning in Enterprise, and we've got branch versioning, which is the newer versioning model, which is used by the utility network, for instance. With traditional versioning, you've got two workflows. You can have a version per map. This is the default. Or you can actually have a version per user. And there's great online documentation. If you go into the ArcGIS Enterprise documentation section online, there's some really nice documentation that goes over this in a lot of detail. So let's have a look at traditional versioning, the default behavior versioning per map. Every time a map is taken offline, a new version is created. And edits to the offline map will be synchronized against that specific version. And this always guarantees the latest data for the published map. So when that version is created, it's, if you like, it's basing it, it's branching from the main line, and so it's always getting the most up-to-date data when that map goes offline. And if you look at the version in the database, you will see its version name is the user ID that took it offline, the feature service that's backing that layer or that version, and then the unique identifier, which makes that version name unique. Now, once you've made your changes, you've got to perform a reconcile and post to push your changes from the version that was created for you back in to the master branch. This is good for quick offline editing sessions, maybe a few hours or up to a day or two, but there's limitations if you want to take something offline for longer than that. So data maintenance, field inspections, it can be supported. Now clearly, every time a map is taken offline, it's creating a version on your database. If you have a number of users, there's a lot of versions being created, and there's a lot of reconcile and posts that have got to happen on the server. So it doesn't scale to hundreds of developers, but it can be used. It's hundreds of users. It can be used for tens of users, as long as you've got the QA/QC processes dialed. So let's take a look at this in sort of graphic form. So we have our default version that's included inside of a web map, and it's there's a feature service there connecting to my version data. When that map goes offline, into this case Bob's collector, then it creates a version, and it creates a version on the server called Bob _ the name of the feature service, and then a unique identifier. Any changes that happen against that version, and then when that version is finished with, there's a reconcile and post that gets happened to push them back into the default version. Now, another model that's available with traditional versioning is version per user. This is where a new version is created for each person taking a map offline. It doesn't matter how many times I take that map offline. If it's the same user, I'll always be taking that map off from the original version. Now, this doesn't guarantee the latest content of the default branch is included in the version when you go offline. It all depends on when that initial offline action happened, and it's only up to date with the master branch at that point, unless you're performing sort of reconcile and post, and you're kind of automating that process. This is probably better for a few days to a couple of weeks, that type of scenario, because it's the back-end processes are optimized that way. So let's have a look at this in a graphic form. We've got my inspection map, and it's hitting the default version. Again, it's included in a web map for inspections. Joe takes the inspection map offline, and there's a version created for Joe. Joe can go offline. Mary has a map that she takes offline. She can go offline. They can stay offline for a while. They can synchronize their changes, and that will push their changes back in to their versions. But there's no real synchronization with default at this point. And then when we see these changes are being made, they go, as I said, they go directly into their versions. And then you can perform a reconcile and post nightly, so you can get your changes that are being created out in the field, you can push them to the inspection version with this nightly process. And there's geoprocessing tools available specifically for this workflow. And then you can see these changes are potentially propagated out to the client. And then finally, once you've performed all of your work out in the field, you can perform a final reconcile and post to the default version. Okay, let's have a brief look at branched versioning. And this is the newer versioning model. It's really been designed and implemented from the ground up to work very well against the WebGIS pattern of working, and it does scale to a large number of editors and definitely scales to a larger number than the traditional versioning does. But it does have some restrictions. You've got to be connected to the default version, and any offline data uses a simple feature model for editing. And any edits that happen out in the field, these create dirty areas which then must be validated inside of ArcGIS Pro before they get, if you like, committed in to the main line as fully accepted features. So using this process does allow it to scale to a larger number of users. So that was versioning. Let's have a look at our sync strategies. So it's important to think about sync. Don't just take the default option and think that that's the best option. So if we have a look at how sync works again, this is a repeat of this session before. We've got our sync-enabled feature service. We go offline, it generates a geodatabase. We make edits to that database. We call sync, which creates a delta. We then upload that delta. If we're doing an upload sync, potentially download any changes that have happened on the server, and they apply to the geodatabase. So that's kind of the flow of data, but there's various options during this process about exactly what happens when you perform sync. It doesn't have to do everything that was just outlined there. So the sync direction really does matter. The default is to perform a bidirectional sync. This is where we take changes from the client and upload them to the server, and we take changes that have happened on the server and download them to the client. It ensures that the server and the client are both in sync with each other. But it's the heaviest and most costly exercise in terms of performance, and you might not need it. If you're not interested in changes that have happened on the server, don't ask for them. Just pass your changes back to the server. Likewise, if you're not interested in pushing your changes to the server, but you are interested in getting the latest and greatest data from the server to your client, just perform a one-way download sync. One of the things that does catch people out often is when you're performing an upload from the client to the server, that's a relatively lightweight operation in terms of server performance. When you're performing a download from the client, it's considered a heavyweight operation because it requires a unique lock to be performed on the server's backing data store. And that unique lock means that only one of these operations can happen at any one time. So think about this scenario. You have a lot of users going out into the field every day collecting information. They come back to the office round about the same time at the end of the workday, and they all perform a sync because they want to push their changes to the server. The correct way to do that would be, let's perform an upload only. Just take my changes and push them to the server, tell me when it's done. Because tomorrow, when I go offline again, I'm going to download the very latest from the server as a one-off operation, especially if it's in a pre-planned scenario. The wrong thing to do is often to perform a two-way sync. I upload my changes, but now I want to download any changes that have happened on the server. Because of this unique lock requirement on the server's database, If you've got 100 clients all performing a two-way sync at the same time, it becomes a synchronous operation. And your sync process will not end until it eventually gets a unique lock on the server database and it comes back to me with the result. So think carefully about your sync direction. And if you can avoid it, try and avoid a download as part of your sync. Sometimes that's not possible, but we strongly recommend trying to manufacture your workflows to avoid it, and that way you won't get this locking issue at the end of the day. Now, if you're just pulling data and you're using the synchronization framework to just pull the latest copy of the data from the server, you can actually do it with a sync option of none. And when you do that, that's telling the server, I just want a snapshot of the data to get the latest copy, but I'm never going to be synchronizing this at a later date. And that allows the server to not create a replica. Because as soon as you download data from the server as part of this workflow, it will create a replica because that's how it's going to manage the internal receiving and sharing of changes between client and server. If it doesn't need to create the replica, then best not to, because you obviously have to tidy these replicas up as part of a back-end process. Otherwise, your server will end up with lots of replicas remaining on the disk. For data encryption, it's a question we get asked quite a bit. Is there data encryption at rest within the runtime? The answer is no, there isn't. There's no built-in data encryption at rest. Currently, we're researching that because it is often requested. So our recommendation is ensure that your users are securely handling their devices out in the field. Make sure they've got a passcode on them or a password protected. And make sure that the disk or the device itself is encrypted. And that way, that offers you the best form of protection. If data security is really a big concern of your organizations, then definitely consider a mobile device management solution where you can have more control over the security of your devices. And finally, just a few tips here. Remember to clean up your data when you finish your offline workflow. If you're on the client, make sure you delete the packages once you finish using them. And there's an API call to allow you to close your offline map, and that'll ensure all the data connections are closed so you can delete the files on your device. Make sure to unregister your geodatabase from the server. That allows the server to clean up its resources. Otherwise, the server's got to keep these replicas around that it needs to support the offline geodatabases that it's created. If these offline geodatabases are finished with, you have to tell the server by unregistering it to allow the server to clean up. So it's good to keep track of that. And then finally, what happens if something goes wrong? And the error messages that you get out of the API, while they're relatively informative, it might not give you the exact details of what went wrong. There's more information in the JSON, which is stored as part of the job. So you can save the JSON from the job, and you can view that, and that'll have a lot more information in there, and that could give you an idea of why your particular offline sync operation failed. Okay, so that's it. That's the end of our third session in the working with ArcGIS Runtime online and offline, and helping you optimize your workflows. Nick and I have enjoyed presenting them to you, and we hope that you've learned something and you're able to apply it to work that you're doing right now. Thank you very much.